All right, thanks very much for sticking around until the end of the day to hear a talk on continuous delivery in the brave new world of mobile. My name's Clay. I'm a software engineer at a company that's actually not too far away from here over in Soma called PagerDuty. And this talk is really an introduction to CD in the mobile world. And I want to answer just a few kind of quick questions with this talk, and then towards the end speculate a little bit about what the future of continuous delivery might be in mobile and where that might end up. I think it's important to first kind of put it in context, like how did I end up learning about this, and where did I come from to kind of actually even care about CD and mobile. I work for a company called PagerDuty, and we are an incident alerting and management solution. In other words, we sit between your monitoring tools and humans in your company. We make sure that the right person gets the right alerts. Mobile's obviously a huge part of that because, as you're well aware, people don't carry around pagers anymore. They use their smartphones. In the engineering organization and at PagerDuty in general, because of the nature of our product, we care deeply. Some people have even called us obsessed about reliability. We know what a big deal it is to miss an alert, or from the application perspective, to actually use the app or use our web app and have it not perform or have it fail in some way. So because of that focus on reliability, and because we care so much that you always get the alerts and you're able to understand them, we've invested a lot in our services and our components to make sure those can be easily deployed and tested. It's interesting though, because with mobile, which is a relatively new team in the company, it's very unclear how to take those same best practices for continuous delivery that we've been using for several years now with different components in our web stack, and how to move those to mobile. And that's kind of where what forced me into this world and caused me to learn more about it. And I'm going to share with you today kind of some of those lessons and some of those lessons learned. To give a brief introduction of continuous delivery in general for those that aren't really aware, I like to start with just a giant red button metaphor. The idea is, if you've designed a really great CD system, you press a button, stuff happens, and you end up with software in a production environment. That's really it. And I'm going to return to the big red button again later in the presentation. To kind of give a more formal definition, and not surprisingly, it comes from Martin Fowler. So, if you look up thought leader in software engineering, his picture pretty much comes up. But it's just a software development discipline where you can release it in such a way that it goes into production at any time. The chart you see over and over and over again in this space is this release, build, deploy, test, release cycle, because it's a cycle and it happens over and over again. That's great, and I think as software engineers and software developers, we've made huge progress in making this a reality for web software and services. For mobile, it's unfortunately a very different story. And a big reason is because of the nature of releasing mobile apps themselves. Certain large tech companies in the peninsula have app stores, or the Google Play Store. And there's a very rigorous, and there's a huge process around releasing. It has to go through a review process, and there are various rules around that. But the idea for web developers or people that are coming from a more web background, you can't continuously deploy to the App Store because they have to go through review keys. So with all of those challenges around mobile apps, it's definitely worth asking at this point, why is it important? Why even bother with the hassle of trying to create some sort of continuous delivery system for Android or iOS apps, given these issues? My favorite quote on this entire subject comes from a coworker, another engineer at PagerDuty, and that's "Mobile is forever." If you're developing a modern software system, there's always this idea of rollback. You can keep calm. A change went out, there was a failure, it went poorly. You can always just pull that back. In mobile, that doesn't exist. There is absolutely nothing calm about a rollback of a bad app release in the App Store or the Google Play Store. For those people that aren't iOS developers, the process for a large company that's based in Cupertino is you actually have to write an appeal letter to the app review board and they have to actually approve your appeal, and then in a certain number of business days, your app may or may not get removed from the App Store. But you're strictly at their mercy. So for a company like PagerDuty that cares deeply about reliability and making sure that the software release always works and doesn't interfere with alerting, a bad mobile release is pretty much like a worst-case doomsday and terrifying scenario. The other piece of this, as far as why I care about it for mobile, is that mobile right now is not very automated for doing releases. It's a lot of button clicks, and that's ultimately time not spent coding. If you're also releasing as an engineer, you really don't want to be fighting with the App Store certificates or provisioning profiles while you're trying to get a release out. So that brings us to what mobile ends up looking like today as an engineer who's developing on a platform. This is a photo of kind of the desk area. You end up with a giant pile of phones, and I think I have it easy because I mostly focus on iOS and there are just less devices, but it then kind of spills over into this pile of Android devices. It's a very manual process that has a ton of different steps. You end up writing code, you test it out in the simulator in your IDE, whether it's Xcode or Android Studio or Eclipse, if you're stuck on that. You then kind of go through the integration or unit tests, you run those if they exist. The end result is you end up with an application binary, an APK for Android or an IPA for iOS. And then if you're somewhat more advanced, you can then distribute those to beta testers using an over-the-air tool. Over-the-air tool, TestFlight, DeployGate, Hockey App, iTunes Connect, Google Play, there are even more. And then that gets it to testers who can actually use it on their real physical phones. After it's on their phones, you can then use another tool, say like Crashlytics, to collect crash reports, and then you can actually reach out to those people that are using the beta builds to get feedback as well. After all that is done, and you're kind of satisfied with how things are going with those beta builds that you've distributed to testers, you can then release it to the App Store or Play Store, which is, of course, another manual process. Not that terrible. It's gotten better, to be honest. But you end up having to go through these web interfaces that Google and Apple provide to kind of stage and release this through the stores. And after all that, you're ready to release, and you kind of just hope it's not terrible and you don't have to do a rollback, or in this case, really a roll forward, because you can't roll back something on someone's device because, of course, mobile is forever. There's a little bit of good news about this. In the past several months, it's become a lot easier to run tests in the cloud. And I apologize for using the term in the cloud. At PagerDuty, we use Travis CI, which is just continuous integration from this company, and it integrates very nicely with GitHub. We use this for almost all of our non-mobile repositories, but the process is pretty straightforward. You push up your code to GitHub. Depending on how you've configured Travis, they'll kick off a virtual machine. It'll run your tests and then report the results back to GitHub, and you'll see this nice little green checkbox in your pull request if the test passed or failed. That's controlled by this YAML file called travis.yml. It's in source control, so it's versioned, and you can kind of declare how you want your test to run. The really nice thing about this is Travis does support Android and iOS. It runs simulators, so not in physical devices. But in this case, this is our YAML file for iOS. You basically tell Travis, hey, listen, I need an OS X image. I need it to be in this Objective-C environment, and run this script, bin tests, which kicks off the Xcode build tool. And depending on the results, post to HipChat the status of whether it succeeded or failed. So it's actually really nice, and it's an easy way to run tests. Unfortunately, to get to that next part, it's where we're actually going to run the tests. If the tests pass, then distribute the build to, say, some internal testers over an over-the-air tool. It's really, really difficult. Travis has some documentation on that, and there's an excellent tutorial on Objective-C.io about how they can actually make it work with Travis. But in general, we're still really early using CI tools or running tests on mobile in the cloud. The first limitation is pretty obvious. You can't test on actual physical devices you own. There are certain startups that are making this a lot easier, But at least in the Travis environment itself, you can't say, I want to run on these 5 test devices or test phones on physical hardware simultaneously. It still continues to be really difficult to configure. You end up in the weeds with provisioning profiles and certificates, and it's just an extremely painful process. And the last thing is, and this is for Mac especially, if you're on the latest and greatest Xcode, those environments aren't always supported in the cloud-hosted CI environments. One thing I know Travis is working very hard on, and I don't fault them at all, is you can't run Xcode 6.3 yet on Travis. They're working on it, but the end results, like a key reason behind that is they don't support the latest version of OXX, Yosemite, on their virtualization hardware yet. So we're blocked from using the version of Xcode we actually develop on in Travis until that comes out. And there's a little bit of a lag there. So we wanted to investigate another alternative, and we actually went to a kind of surprising solution, and that's Apple's own Xcode Server. It's really interesting, and it's a very aptly solution. Ultimately, you end up with these things called bots, and they run inside of Xcode. They do their own thing, and you end up with kind of a pass or fail that pops up in Xcode itself. And this is where I'm going to slightly switch gears and talk about iOS specifically. But it has a lot of advantages that were really appealing to us right off the bat. The first is you can actually test multiple physical iOS devices that are connected to the macOS server simultaneously. So you can actually connect whatever old iPhones and iPads you have lying around. You can open up the bot and say, I want to run my tests on all these devices. And it actually works. It integrates directly inside of Xcode, which is nice. And your private keys stay out of the cloud. So a big security concern, and something that should obviously make your security team very nervous, is if you're distributing your apps through some cloud-hosted solution, you have to upload your private keys that sign your apps to the cloud. With this, at the very least, they stay on physical hardware in your office itself. Unfortunately, we kind of end up in the same place we end up with other CI solutions, and there's a fairly difficult amount of hackery needed to actually get it to work. I'm not going to go through this list exhaustively, but it's pretty much the easiest way to ruin your Friday afternoon as an iOS developer. Some key takeaways from this is, as is often happens with iOS development, you have to go to really extreme lengths to get private keys, certificates, and provisioning profiles working. There are lots of different resources on the web about how to do this, but it's painful, and it involves you going to the OSX server and copying provisioning profiles to the secret directory. Another thing, if you're using CocoaPods is a very popular dependency manager for iOS and macOS projects as well. If you're using a private CocoaPod, you actually have to go to the server, generate SSH keys for that OS, that Xcode Server user, and kind of just shove them in the keychain. It's very messy and not at all ideal. That said, it is surprisingly extensible. There are triggers that you can run before or after a successful Xcode Server build, after a bot integration, as they call it. And if you look at the environment variables, they actually expose almost all of the state of the iOS builds, or the iOS integration. And some of the really interesting things, or the things that were interesting for us, are the archive path and the product name. It'll actually, if you wanted to, you can actually generate the IPA file that's ready to distribute to users, assuming it's been signed correctly and you've gone through that horrible configuration process, which actually ends up being really nice. The only downside, of course, is you're still kind of stuck in Xcode land. If you're not an engineer or you don't have your development environment set up, there's no way to trigger these bots unless you're inside Xcode. However, it turns out they have this semi-secret Xcode Bot Server API. If you look at the traffic between Xcode and the Xcode Server, it's actually just using a JSON REST API that appears to be written in Node.js. I had no idea that Apple was using Node in this way, and it was kind of surprising. But assuming you're authenticated, it's pretty much a one-line curl command to say, hey, given a bot ID, and the bot ID was available in the environment variable right there, you can actually just post an empty request body and it'll instantaneously kick off the build. So the end result is there is a super hacky way using this private API to actually kick off any arbitrary integration, which of course is really appealing because it gets us to this pseudo push button world where, yeah, I mean, whether you're in Xcode or you're running a shell script that hits this endpoint, you can actually get a successful build out of Xcode Server. The really nice thing is they also expose a web interface, so you can actually open up your browser. It looks nicest in Safari, of course. And you can actually download the archive or the product and see the results using pretty Apple graphics. It ends up being really nice too if you have a spare television monitor around. They actually kind of have this kiosk mode thing that's this kind of beautiful Apple typography, and you actually see the latest build status. The nice thing about deploys, or these deploy triggers as well, is upon a success, after a bot successfully integrates, it's not that difficult using these before and after triggers to say, hey, I want to share my build status with the chat room, or I want to actually upload that IPA for testers on deploy gates, Hockey app, or Crashlytics. And these before and after steps in the Xcode Server land are just called pre or post triggers. So ultimately, after all of that for iOS, we're kind of sort of there. It's not entirely satisfying because you end up having to find an old Mac, probably an old Mac Pro or an old Mac Mini, and you have to kind of go through these steps, and then you actually have this physical hardware somewhere in your office that can kick off all these builds. That said, it does work, and it does support simultaneous testing. It does support testing on multiple physical devices you own simultaneously. So it has a lot going on for it. And I think there are pros and cons to each solution, but it would be really interesting to see what's going to go on next with WWDC in June. And speaking of what's going on next, there's been a lot of change and consolidation in this space in general. I think it would be basically negligent of me to not mention two startups in this space that are attacking this same exact problem, Ship.io and Roboto. They're trying to make the entire process I just described, the pulling out of the hair with provisioning profiles, certificates, private SSH keys, and all that, to kind of just come up with a cloud-hosted solution where, hey, you give it your repository, you say, here are my credentials, go press a button, and it'll give you a thumbs up or thumbs down, and automatically integrate with all of your over-the-air tools and your chats, whether it's IRC, Slack, or HipChat. So it's really, really going to be interesting to see where these two startups go and how they'll work. The other kind of big question mark for this space in general is what's going on in Redmond's, Cupertino, and Mountain View. There have been a lot of acquisitions. TestFlight is now owned by Apple, Hockey app, Microsoft, Crashlytics, Twitter. There are a lot of different tools out there that are solving bits and pieces of this problem. And all of these features, Crashlytics included, are continuing to add more features to kind of capture more of this pie. So it's a really interesting time to be a mobile developer because it could be the case in 3 months that one of these products or an entirely new product really simplifies the entire space in a big way. And of course, a large technology company in Cupertino has a habit of making very big announcements in June in WWDC about kind of the new direction they're taking these products and how that's helping developers. In any case, depending on whatever approach you do end up deciding to choose, I hope you can at least be like this guy and say you knew about mobile continuous delivery before it was cool. Thanks very much for having me today. There's the PagerDuty booth right outside if you have any more questions. I'm also on Twitter, and I'll be sharing these slides with the resources attached eventually and hopefully very soon. But thanks again, and thanks to the conference organizers for having me.